This is going to be Topic 2, Research and EMS. And the key concepts that we're going to talk about in this lecture are going to be paramedics and their continual evaluation of their practices, protocols, and procedures, the connection between paramedic practice and evidence-based practice, different types of research appropriate for differing research questions, the research format and the ability to identify errors, ethical concerns associated with research, and the types of research that can improve the bottom line. So first of all here, we're going to talk about practice protocols and procedures. And for the most part, they've originated from anecdotal experience or common sense, a correction of earlier misadventures. Now, anecdotal experiences are, well, gosh, this worked in the past, I believe it will work again in the future. But it's not evidence, and we're switching to an evidence-based model, so unless we can prove that that is the appropriate thing to do, in the future we probably won't be doing it. The paramedic practice is more likely to be a function of what does not harm the patient, may be ineffective or lead to defensive medicine. I had to retreat to this point, and from there I attacked, look at practices from the scientific advantage. And from the scientific advantage, it's the best way to determine effective paramedic practices. The scientific method. Knowledge acquisition through objective observation and reasoning. And what the scientific method does is it corrects misconceptions, it integrates new conceptual frameworks for the paramedic practice, and it leads to improvement of patient care. Examples of the research. Limited resuscitation, it was used in the book, or permissive hypotension, may be more advantageous than previously thought. So we might want to not try to get that blood pressure up to 100 millimeters of mercury. The fallacy, or incorrect actions of replacing blood loss with intravenous solution in a 3-to-1 ratio. So we can easily dilute them out and give them an anemia of sorts. Purpose of scientific research is to establish a paramedic's practice that is defensible. Evidence-based medical care in specific circumstances can be independently evaluated and can be applied to a number of the same or similar circumstances. And this is the most effective means of delivering desired patient outcomes. Evidence-based practice. Critics say EMS is costly to the public and an ineffective means to deliver patient care. Paramedics must prove their practice is valuable. It decreases morbidity. The first step is to look at the existing research. So EMS research, however, is kind of limited. So we look at other allied health professions and hope that we can share some of their practice issues. And this may reveal to us some clinical research on subjects that could be applied to paramedicine or EMS research. This may also look at research from other professions. An example of this would be business operational issues or from companies. An out-of-hospital setting practice are kind of unique. So what we're going to see with this is EMS research is limited, and the models that we get from other companies and other allied healthcare professionals, they may suggest impractical solutions whenever we look at it back on pre-hospital care. So the best support for pre-hospital care comes from pre-hospital care. So the best support is getting or setting research in the pre-hospital setting. Performing a literature search. Ask key questions. An example of this is going to be, does the paramedic pediatric intubations, and this is an example from the book, does pediatric intubations by paramedics improve patient outcomes? Once we get that information, or once we find varying literatures on that, we can start formulating kind of a thought process. But this is just talking about how to do a literature search. So perform a search of the current literature and published research reports We can look at peer review academic journals, circulated among field experts for critical analysis. And there still may be errors to this whenever we put all this stuff together. So if we're trying to formulate a hypothesis from literary research, we should carefully review our conditions here. Other ways of finding information are going to be computerized searches. Medline is an example of this. Take a look at their abstracts, and abstracts is like the start of their research, and see if we can formulate something off of those abstracts. Review a reduced list of studies directly, online or medical laboratory. Reference librarian may actually offer help in this. Reviewing the literature. And there's several ways of looking at this. Retrospective research, data dredging, and then prospective research. So we're talking about different types of research here. And what we need to do in reviewing the literature is identify the kind and type of research that was performed. Now, most common kind of EMS research in the literature is retrospective research, which is kind of looking in the past. The question is raised, and past practice patterns are looked at for effectiveness. This is often used in performance improvement, but it's dangerous because we have a numerous amount of variables that cannot be controlled. We weren't filtering, if you will, the amount of people that we were running this on when we looked for this information. Everybody that fit into a criteria now is looked at. Randomness may explain the actual results of this. So if we see random numberings on this or random data from this, the results might be explained because we didn't focus our target group to begin with, especially when we were looking in the past. Data dredging. Conducted research without a question in mind. So application of mathematical test or statistical significance to data and trying to observe for any pattern that is data and attempting to form a cause and effect conclusion, that really isn't scientific research. So prospective research, whenever we look at it, is the most scientifically valid. An attempt is made to account for everything that we can predict and everything that we can't predict. So all predictable and known confounding variables, to control those variables, and then add a treatment. If change occur, the treatment may have caused it. So then that reinforces or gives us an alternative hypothesis. One of the ways we can do this is a double-blind randomized clinical trial. Prospective scientific study controls the known and unknown variables, leaving only one variable to be manipulated. The subjects are chosen at random. An experimental group is compared to a control group, and then off of that a conclusion is drawn. Statistically equivalent groups lends credence to the results. So if they have the same demographics or they can be applied, well, these are almost the same patients, all of that reinforces your hypothesis at that point. Clinical trials. We have single-blind study, double-blind study, and then we need to talk about placebos or shams. So a single-blind study, the subject doesn't know what group that they're in. So in the single-blind study, they do not know that they're being assessed, if you will. The double-blind study, the researcher and the participants both are unaware in which group the subject is in, whether they're in the actual group that's being researched over or which they're in the control group, or they may not be in any group at all. And this may use placebos or shams, but there's some ethics involved in this as well. A placebo would be an inactive drug or maybe an inactive device, but we cannot... An example of this, let's say that the person needed ventilated. We aren't going to have an absolute inactive device that will not ventilate the patient. So, to some degree, there needs to be ethics applied to this, and we'll talk about this later on in the slide set. Statistical evidence. Classical hypothesis testing. This compares the results of two treatment groups statistically to obtain a degree of confidence that the treatment caused the effect. Now, we get variations in this. A null hypothesis is used to calculate the probability of a random chance that causes change, and the value on this is the p-value. A null hypothesis assumes that the treatment did not cause the effect. The calculated p-value in this part of this is the probability of random chance causing the changes rather than the actual treatment. And then in the medical profession in general, we generally have a calculated p-value of about 0.05 as a standard value. The calculated p-value can also be compared to a prior selected p-value for a similar type study or the same study. That would be chance of probability. Types of research. We have descriptive studies. States the prevalence of a condition, often illustrative of a problem without trying to offer an explanation. Case reports or case series are an example of this. Unique cases help gain insight that can lead to further research. A cross-sectional survey, that's kind of a snapshot of a certain aspect of a population at a given point in time, obtained through observation. An example of this would be obesity. An ecological study, this is a correlation study, provides information about disease trends and rates within a population, used to show need for research grants or funding for special projects. Observational studies. Ask a question that poses a simple explanation or hypothesis. The extra variables in this, or the confounding variables, must be controlled to a T. We have case control study. Cases are compared to the actual control studies. Procedures performed on both are examined to see if there was an association between the outcomes. And then there's a cohort study. Examines patients who have been exposed to a treatment and compares them to a group that was not exposed to that treatment. The patients are followed to determine their outcomes. This is varying types of research. Experimental studies. Classic research starts with a suggested explanation why something occurs or could occur. With the hypothesis in mind, the researcher uses the experiment to test if a treatment created the predicted change. We get hypothesis from this. We get two hypotheses from this. A null hypothesis assumes treatment did not cause the change. An alternative hypothesis assumes that the treatment is plausible explanation for the change. Statistical tests are then applied to the outcome data, and the results of this either support the null hypothesis, it did not occur, or this is not a good idea, or the alternative hypothesis, which this is what caused this. Errors in research. Type 1 error, which is a false positive, rejects the null hypothesis and accepts the alternate hypothesis when the fact is not supported. Now, what this means is this may either lead to the wrong conclusion or may ignore that the patient's conditions could have an alternative explanation. So you rejected that, hey, this had nothing to do with what I did, and you have picked or chosen your scientific hypothesis that you have made. And this is a type 1 error. Type 2 error, false negative, incorrectly failing to reject the null hypothesis. Failure to observe the changes created by the treatment when one did occur. So even though you have created a hypothesis and now you have been given proof that this hypothesis is correct, you still have rejected the hypothesis or the alternative hypothesis in this. Give patients false reassurance that the treatment was effective, may be caused by limitations of the study group, the study group size, the places on the experiment, and then pretty much what we learn here, what we see is that if we have a small study group, they pretty much lack power or lack the ability to give us the numbers and the scientific data that we would like to see. Meta-analysis in pre-hospital research. Meta-analysis in some cases is difficult to obtain a large population for the study of subjects. So meta-analysis is used to correlate other smaller studies so that we can get some of the same results. Results of the several similar small studies are combined and a statistical hypothesis test is applied. The original research, however, whenever you're looking at this, other varying studies, must be methodically sound. Pre-hospital research. Person doing most of the data collection and the analysis is usually cited as the lead author. However, this is going to take a whole team to achieve the information and the data collection that we want. Carefully consider the hypothesis before committing. The words "do no harm" should be at the core of every research project. Research should reasonably expect, if you're doing it, to improve the patient's condition. Which leads us to ethical concerns. They have made something for this. It's called the Nuremberg Code. It's a set of research rules adopted after World War II. They are guiding principles that limit the scope and the nature of the experiments using human subjects, and there are essentially 3 specific criteria in this code. 1. Respect for the person's freedom and dignity as manifested by informed consent. Now, I know we haven't went over legal yet, but the patient must have informed consent, and we will come back to that in legal. 2. Any person mentally incapable of making an informed decision could not willingly consent to participate in research, and this is called diminished autonomy. 3. One group of people should not bear all the risk of the research when the benefits of said research could benefit all persons in a larger society. And this is the third one, justice. Research should not be permitted to begin or continue if the researcher reasonably believes that death or permanent disability could occur. If the patients receiving the experimental treatment are showing marked improvement, or they're really headed in the right direction over those receiving standardized treatment, then standardized treatment must be stopped and the new experimental treatment offered. To ensure this, you need to develop and keep put in play before any research goes into play a data and safety monitoring board. And this board essentially ensures the standard. Institutional review boards. This is different than the previous data monitoring board. An institutional review board reviews research proposals and protects the rights of the patients. And it protects the rights of the patients from unscrupulous researchers. Independent ethics committee ensures human rights are not violated and standards are upheld. An institutional review board is mandatory for any federally funded research. Emergency circumstances. Informed consent may be impractical in some situations. In these situations, you may call for an exception. If the patient is capable of consenting if the patient is incapable of consenting due to the medical condition, a form of consent similar to implied consent may be utilized. Regulations currently require that the public be informed of any clinical trial that's going on in the area. Attempts to establish informed consent before the emergency and advise the population of their right to refuse or to participate. Economic research. Economic analysis. Some professional practices question not directly involving patient care, but rather matters of operational or costs. And we're going to talk here a little bit about a cost-benefit analysis. Now, I would suggest even later on, whenever you're in treatment, you do a cost-benefit analysis, but in a different way, and I'll explain that here in just a second. A cost-benefit analysis asks the question whether it is advantageous, and in this example they're using cost-effective, to take a particular action or make a change in a procedure. Later on, whenever we're in the treatment section, I would like you to use a threat assessment or a cost-benefit analysis in the aspect of, is it worth the risk for this patient? If we give this drug, we may have these untoward effects. In this condition, in my opinion, is it worth the risk? Absence of research. Best practice. The method of delivering care is the most effective and superior means of providing care. That is best practice definition. Requires compassion of one paramedic's practice against the other. So we're going to compare models, if you will. And self-improvement. Best represented by the concept of Kaizen, and it emphasizes a process and a system thinking. Now, Kaizen is kind of a business thought and business process that Japan uses, and essentially it is self-improvement. Continual self-improvement. So instead of somebody else applying quality improvement upon you, you provide self-improvement into the equation. So you're continuously improving your product. Conclusion. For paramedics to attain and maintain professional status in the industry, they should continuously ask, does what we do really help? Must be prepared to change field practices as evidence demonstrates. New and improved means to improve patient care. If you have any questions concerning this topic, feel free to contact me. My name is Roy Smith, SmithArt, SamaritanEMS, OK.com, or 405-492-8243. Thank you.